Well, happy Friday, everybody. I'm trusting that you guys are actually getting to this today since your teacher's on top of his game this weekend and has it all posted nice and early on Friday afternoon. This actually should be up by probably about 2:30. It's 2:12 now. Um, so we've been dealing with absolute value inequalities, and we're now going to go be finishing it up actually right here with graphing absolute value inequalities. Um, and when we're doing these, there's one thing that really helps, and it is actually called converging and diverging. And I'm looking for you guys to have this in your notes, and you need to have the definition of the word converging and the definition of the word diverging in your notes for Monday. Um, and I'm not going to give you the actual definition. I'm going to let you look that up. But what I will tell you is if you think of converging, you think of, like, if you think of traffic as converging, it's coming together. Okay, so we're going to take an equation like absolute value of x is less than or equal to 4. And then we're going to take one that's the absolute value of x is greater than or equal to 4. And I'm going to show you what the difference is between converging and diverging. Now, when you think of converging, you think of coming together. Well, that's pretty much a self-explanation of what a converging inequalities graph will look like. The answers will be coming together. They will be in between two different numbers. There will be a low number and a high number, and all of our answers will be somewhere in between. Diverging, however, is the exact opposite. It's going away from each other. They're separating. So when you think of the graph of an absolute value equation that's diverging, the answers will be going away from each other. And actually, more specifically, going with what we've been dealing with solving these, this is what we're going to call an AND statement, and this will be an OR statement. For the AND, our solution will fit both of the equations. And for an OR statement, if you remember correctly, it's either one or the other. The solution doesn't fit both. It only fits one or the other. So if we use our typical thing and we make our two equations, you have x is less than or equal to 4, and you have x is greater than or equal to negative 4. Well, in this case, my solution, any number I pick, which is a solution, is going to be between the number 4 and negative 4. Because let's say we pick the number 0. Let's say x equals 0. Well, 0 is greater than or equal to negative 4. That is true. But 0 is also less than or equal to 4. And that will be true for all of them. So what you do is you write them together. Negative 4 less than or equal to x less than or equal to 4. Okay? And you can tell that what I was talking about the answers being in between the two numbers, because here you can write x in between the two numbers. Okay? Now when you deal with this, you make your two equations, x is greater than or equal to 4, or x is less than or equal to negative 4. Well, if I pick a solution for this, greater than or equal to 4, let's say x equals 5. Okay? X equals 5, it's true for this one, but that's a false statement here because 5 is not less than or equal to 4. So you'd have to say x is equal to 5, or you could say x is equal to negative 5. Okay? Because negative 5 is less than or equal to negative 4, but it is not greater than or equal to 4. So it's one or the other. So in a problem like this, it has to be written separately as x greater than or equal to 4 or x less than or equal to negative 4. And this is how the answer is written for a diverging, and this is how the answer is written for a converging. Okay? So now let's get into the actual graphing part of it. All right, so you have 2 times absolute value of 2x minus 1 greater than or equal to 13. So in doing these, we're going to have to do exactly what we've had to do all the other times. We have to start by solving the problem. Okay? So I'm going to start by adding to 1 for both. Okay? And I get 2 times absolute value of 2x minus 1 greater than or equal to 14. Now I'm going to divide by 2, and I get the absolute value of 2x minus 1 is greater than or equal to 7. Now you're going to make your two equations. So I've got 2x minus 1 greater than or equal to 7, and I've got 2x minus 1 less than or equal to negative 7. Okay, and I am actually going to separate this. So let me do it this way. Let me erase these. Move my line down just a little bit. And that'll be what we graph on. And I'm going to go ahead and put another line in probably about right there. And let me put one of these in so that I can continue writing. Okay, so now you're going to, so I'm going to add 1 to both sides. I get 2x greater than or equal to 8. Now I'm going to go ahead and continue that over here. And I'm going to divide by 2, and I get x is greater than or equal to 4. Here I'm going to add 1 to both sides. I get 2x less than or equal to negative 6. I'm going to divide by 2, and I get x is less than or equal to negative 3. Now, if I choose a number that's greater than 4, let's say 5, that doesn't fit this. So this is an OR statement, and this is what we consider to be diverging. Okay, now when I do my graphing, okay, I'm going to leave it up to you, but I'm not too picky on the graphing part. What I am picky about is this. Your numbers have to be graphed correctly. So the smaller number has to be on the left, the larger number has to be on the right, and you have to have some numbers in between. So since I have a positive and a negative, I'm just going to put 0 in the middle. I'm going to put, let me actually erase that, put it in a little different spot. I'm going to put 4 right here. I'm going to put negative 3 right here. I'll put negative 6, and I'll put 6. Okay, so I am going to start by putting a dot on the numbers. Now, same as what we did when we just graphed an inequality, open or closed is based on whether this is greater than or equal to, or if it's just greater than. Okay, so this is greater than or equal to, so it's a solid circle. And this says it's greater than or equal to 4. So one way you could think of this is pick a number on each side. 0. Is 0 greater than or equal to 4? No. So I don't want to graph my arrow towards 0. 6 is greater than or equal to 4, so I want to graph my arrow towards 6. Okay? Now I'm going to go to the next one. X is less than or equal to negative 3, so I'm going to put a closed circle at negative 3. And less than or equal to, well, 0 is greater than negative 3, so negative 6 is less than negative 3. So I'm going to go towards negative 6, and this would be my graph. And this is diverging, and you can see that the answers are going away from each other. This one you have going to the left, this one you have going to the right, and there's a space in between where there is nothing. So this is what we call a diverging inequality. Okay? So now, let's go ahead and look at, and this actually should say example number 2. Okay? And it's the same idea as what we just did. So we're going to start by solving the inequality to start with. So in this one, everything is, the absolute value is by itself. So I can make my two equations. I've got 3x minus 2 less than 12. And I've got 3x minus 2 greater than negative 12. And now you solve. Add 2 to both sides. You get 3x less than 14. Divide by 3, and you get x is less than, and that's not equal to, so I can erase that, less than 14 over 3. Add 2 to both sides, you get 3x greater than negative 10. Divide by 3, and you get x is greater than negative 10 over 3. Okay? Now, let's look at the inequality. Well, let's actually start by graphing. So I'm going to put 0 because I have a positive and a negative. I'm going to put negative 10 over 3, 14 over 3. Now pick another number that's smaller and another number that's bigger. So 14 over 3, that is going to be more than 4 but not 5. So I'm going to put 7. And negative 10 over 3 is more than 3 but not 4, so I'll put negative 5. Okay, and now if we graph, we're going to start at x is less than 14 over 3. It's not equal to, so it's an open circle. Now it says less than. Well, 7 is greater and 0 is less. So I want to go towards the 0. Okay? And now on this one, I'm going to put an open circle at negative 10 over 3. It says greater than. Well, negative 5 is less than, and 0 is greater than, so I want to go towards 0. Now you can see that my answers are between these two numbers. So I can pick any number between this one, and it will make my inequality true. Okay? And the answers are coming together. So this is what we're going to call a converging inequality. Okay, which means you have to write your answer together. So negative 10 over 3 less than x less than 14 over 3. And this would be the answer to your inequality as well as the graph for the inequality. Now, I am going to show you a shortcut that is always true. So let me pick some colors here. This right here, this is less than a positive number. Okay, so I'm going to go back to the converging thing. So we have less than a positive means it's converging. Okay, and if I look at this one, I have greater than a positive. Okay, and with, let me write it down. So if I have it's greater than a positive number, then it's diverging. Okay, so converging is less than a positive number, diverging is greater than a positive number. And that will always be true. Now, it's not true until the absolute value is by itself. Okay, so right now, my absolute value is not by itself. So if I look at this originally, I'm not sure yet. I don't know for sure that it is converging, or excuse me, it's diverging until I get to this spot right here. Once I get the absolute value by itself and it is greater than a positive number, then it's diverging. Now this one, the absolute value is already by itself. It's less than a positive number, which means this one will be converging. Okay? Now you have to have the absolute value by itself first, because if you take an example like this, and let's say that this was a negative 2, well then when I divide, it's going to change this, which means it's no longer going to be diverging. It's probably going to end up being no solutions. Okay? So that's what you have to be careful for. You have to have the absolute value by itself first before you can determine is it converging or is it diverging. Okay? This is a pretty simple concept, especially if you can learn what converging and diverging are and the differences between them and what the graphs look like of a converging and a diverging inequality. I trust that you guys will have a good weekend. I know that I am planning on being somewhat lazy this weekend, maybe get some Xbox in finally. But I will get all the stuff finished up grading for 6th period. The only thing that will not be graded will be the tests. I'm still going to wait until now. It'll be Monday once everybody gets done. So I hope you guys have a great weekend, and I will see you guys on Monday afternoon.